Okay, so in this video we're going to have a look at bearings. So grab a piece of paper, grab a pen, make some notes, and we're going to get started having a look at a few different types of bearings questions. Now I'm not going to have a look at any of the bearings where you've got to use a protractor, but obviously if you have to measure out an angle using a protractor on a particular bearings question, hopefully you already know how to use a protractor and you'll be able to put some of these angles in yourself. But I'm just going to have a look at bearings where you don't need to use a protractor for the moment. Now this question says work out the bearing of B from A. Now there's a few things that we need to discuss when it comes to bearings. For starters, there's three really important rules. When it comes to bearings, we always measure from north. Okay, so I'm just going to write these down to the side for the first one. So we measure from north. So north is just going to be our starting point for all of our bearings, okay, and that's going to be absolutely crucial. Obviously we've got to have a place to start from, and north is obviously just quite an obvious one to go from when we're measuring a particular degree when it comes to directions and bearings. So that's our first rule. We've got to measure from north. The second one is the direction we measure in. We measure clockwise. Okay, so we always go clockwise. Okay, no particular reason why, it's just that we obviously have to pick one of them out, what clockwise or anti-clockwise, so it just seems obvious for us to go clockwise really. And our third rule is that the bearing has to have 3 digits, okay, so all bearings have got to have 3 digits. So that means something like 20 degrees, okay, it would be written as 020 degrees, okay? So obviously it doesn't apply to any numbers that are already 3 digits, like 120 degrees would always be 120 as it already has those 3 digits. But if any numbers don't have 3 digits and we're given a bearing like that, we will use 3 digits. So there are 3 really important rules. We're going to measure from north clockwise, and we're going to use 3 digits and apply that to any numbers that aren't already 3 digits, okay? So this question says work out the bearing of B from A, and the language is always quite nasty. You know, you've got to get your head around it just to start with. Once you've got your head around it, it's fine. But it says work out the bearing of B from A. So you just have to look at that second bit really. Look, we're going from A. So if we imagine we're a little person, we're standing at A, there we go. We want to know how to get to B basically. So what's the bearing of B from A? Okay, and we'll have a look at all the different types of language as we go through this. But if we're standing at A and we want to get to B, bearing in mind that we're going to be facing north, that means to get to B, the bearing is going to be all the way around clockwise to this line here, obviously B being down here at the bottom, so that line with the B at the end. So we've got to figure out all that direction going across now. This diagram's quite nice, look, because it's put this little dotted line going downwards just to sort of show us this obviously straight line going south. Now that may or may not be there, okay, but obviously this one is. So all we've got to have a look at really is how many degrees that is now. Facing north, to get to south, look, that is a full turn. So that's a full 180 degrees. So it'd be 180 degrees for us to turn just to be facing south. Then there's this additional 40 degrees. So all we need to do is add those two together. So we have 180, add 40, and that will give us a combined total there for our bearing of, let's have a look, 220. There we go. So our combined bearing there for those two little parts to get to B from A is 220 degrees. Okay. And there's the end of that question. All right, let's have a look at something different. Okay, so this question says work out the bearing of B from P. So again, here's B, here's P, and we're going from P. So again, let's just imagine we're standing at P and we've got to turn to get to B. There's my amazing drawing of a little person there. Right, so we're standing at P, we're trying to get to B. Let's have a think of what we need to do. We need to get all the way to here, plus the rest all the way around, all the way to this. So we've already got part of it there is 60, not that we need to write 60, but remember as a bearing that would be 060, as an angle it's 60 degrees, but as a bearing that's 060, plus we need to find what is left over or what's remaining in that little gap there. So obviously 360 degrees in a full turn, so we can find out what angle's missing here just by applying a normal angle rules. So in total so far we've got 140 there and we've got the 60, combining those is 200. So if we take that away from 360, that tells us the little gap there is 160 degrees. And there we go. So as an angle there, that's 160 degrees. So our combined total then, when we're looking at obviously combining the full bearing, it goes the full 60 plus the extra 160, and that would get us facing the B direction there. So all we need to do is add those together. So 60 and 160, add those up, and that we get 220 degrees again. There we go. So 220 degrees is our full bearing in this question. Okay, so obviously just a few little examples there, just thinking about bearings. Obviously we're measuring from north, we're going clockwise, and we've obviously got those 3 digits going on, although that hasn't actually affected any of our answers yet. We just need to bear that in mind for future questions. Right, one more to have a look at before we have a go. Okay, so this question says the bearing of B from Y is 228 degrees and the bearing of S from Y is 118. Work out the size of the angle BYS. Well, let's start to put some of these sort of bearings on the diagram to start with. So B from Y, so standing at Y, so from Y all the way around to B, that angle there is 228 degrees. Now something a little bit different in this question, look, because now it says the bearing of S from Y is 118. It's not the nicest to draw that on top, but basically this angle here, there we go, is 118 degrees. Right, there we go. So this is another little trick to be thinking about with sort of the future of this topic and where it leads, and how to find these sort of missing gaps. So if part of the angle there, the one that I've drawn in green, is 118, and then extending that all the way to the B gets me to 228. And we want to know the size of this angle here, which obviously we've not been given in terms of a bearing because neither are pointing north, but we can actually find the gap in between them. So from 118 up to 228, well, the sum that we do 228, take away the 118, and that leaves us with 110 degrees. There we go. So that angle there that it's asking for in the question would be 110 degrees. There we are. We could even go a little bit further. You could even find this one here if we wanted, obviously, because it's got to add up to 360 and it's 228 up to that point, so we could find that as well. But that missing gap there has to be 110 based on those two bearings that have to add up to 228, with one of them being 118. So there's a couple of little different things to think about when it comes to bearings. Obviously, just practicing moving from north, and practicing going clockwise, and practicing obviously writing in 3 digits if it does come up. But here's a couple of questions for you to have a go at. Okay, so there's 2 questions there, very similar to ones that I've already gone over. So have a look, try and have a go at these, pause the video there, and we'll go over the answers in a sec. So the first one, find the bearing of B from P. So we want to get to B, we're standing at P, so we've got a 56 degrees there, plus a little bit more, so we need to find out what that missing gap is there. So if we add together what we've got 145 and 56, and if we add those together, I'm just going to do this on the calculator, we get, well, I definitely don't get that, I press times, there we go, 145 plus 56, that gets us 201 degrees. So at the moment, we want to take away 201 degrees from 360. There we go, take these away. That's going to tell us what's left over there. So 360, take away the answer is 159 degrees. So that missing angle down there, if we get rid of this, that is 159. Now obviously to get to B from P, we need to go all the way through the 56 and the 159. So if we add those together, 56 plus 159 gives us our total combined bearing there. Let's have a look what we get. We get 215 degrees. There we are, 215 degrees as our final answer for that question on the left. Right, on to the next one. It says the bearing of B from Y is 246. So all the way around is 246. Then it also gives us the bearing of S from Y. So this direction here, just up to that S line, is 122, and it wants us to work out the angle in between there. So the angle in between, we can work that out very similarly to the last one. We'll take them away from each other. So 246, take away the 122, and 246, take away 122, equals 124 degrees. There we go, so 124. We can stick that down there, 124 degrees. There we go, and there's our final answer for that one. There we go, so just a nice little, hopefully a bit of easy practice there, thinking about the direction of bearings. Let's have a look at something a little different. Right, okay, so this question doesn't have a diagram. Now it says C is a town, and it says the bearing of C from A is 50 degrees. Find the bearing of A from C, so going back in the other direction. So if we want to get to C and we're standing at A, let's sort of imagine a little diagram here. So we're standing at A, and we're trying to get to C, so this is A. Now obviously we need to measure from the north, so we're going to draw a north line in ourselves. There we go, and we're going to imagine just walking off in about a 50-degree angle, so it's by no means perfect, it's just a sketch, but there we go, that gets us off in a 50-degree angle, and we're not going to write 050 there because it's just for the purpose of our diagram, and it gets us up to here, and now we're at C. And if I draw another north line in, there we go, and just imagine this is north. Right, let's move that down a little bit. Right, so the next step is to be thinking about what the question's actually asking now. So it's asking us to do, it says find the bearing of A from C. So now we're at C and we want to know, well, how do we get back to A? Now there's a couple of different ways that we could think about doing this. So I'm going to talk about 2 different ways, and it's up to you which one you prefer. I'm just going to discuss these 2 different ways. Now, one of the ways that I like to do this question is I like to think, okay, well if I just kept walking from A to C and I kept on going, look, let's just imagine we extend this line. So so the line's going to be extended. Now this angle here, okay, is actually corresponding with the 50 degrees down there, okay, thinking about your parallel line rules, because these two north lines are parallel. Okay, so it creates that F shape, it creates that corresponding angle. So actually, corresponding angles are equal, so we can say that this is also 50 degrees right here. Okay, so now we know that to get from C to the same direction we were going in before, it'd be an extra 50, and then we'd have to turn round a complete 180 degree turn, and that would be an extra 180, and then we could add those together to get the full bearing there, going clockwise from north, from C back to A. So if we add those two together, look, we'd get 180 plus the 50, and that would leave us with 230 degrees for our bearing going back the other way. Now that's one way of doing it. Now there's another way that you can think about it as well, so I'll talk about that one as well, and I'll probably use sort of both of these methods as we go through, but we'll have a look, and I think I'll just decide in the moment which one I'm going to use at the time. So the other way we could do it, so let's have a think about this. Now we're talking about parallel lines, so if you think about this as well, if these two are parallel lines, what we've actually got is a co-interior angle there, okay? These angles form that C shape, and we've got a way of working out that one there. Now these co-interior angles, they add up to 180, okay? So if these two angles add up to 180, we can work out the size of that. Look, I can do 180, take away 50, there we go, and that would leave me with 130 degrees for this angle here. Now if that angle there is 130, we already know that to get back to A from C, we have to go the remaining angle all the way around here, and those two there have to add up to 360. So instead I could do 360, and I could take away that 130, and that would leave me with 230 degrees. There we go. So both give us the same answer, obviously. Both are correct, both are good ways of doing it, but I think it's important that you know both of these, because particularly this co-interior angle method, that is used as you progress this topic onto some of the harder questions, okay? So you might need one or the other. Sometimes you can get away with just extending the line, sometimes you're going to need this one, okay? But it's important to know the both there, because obviously we're thinking about parallel line rules as well. But let's have a look at another similar question to this. Okay, so this question says A is a town. The bearing of A from B is 225 degrees. Find the bearing of B from A. So let's imagine we're standing at this town again. So we're at A, and it's going to go over to B. Let's just imagine it's over here again. There we go, pointing our north lines. There we are. And it says the bearing of A from B. So that is going the other direction this time. Look, it's given us the larger one coming back. So A from B, there we go, is 225 degrees. And it wants us to find the bearing of B from A, so it wants us to find this one. There we go. So a couple of different ways that you could do this. Obviously we could think about extending the line, chopping 180 off that and finding this little angle here, which is obviously then going to be corresponding. Or we could just apply these co-interior rules again, so we could find this angle here. So again, it's up to you, but let's just have a look and see how we might do that. I'll do it both ways again. So if we do 360 and take away the 225, that'll tell us what's missing there. And that leaves us with 135. So if this angle here is 135, the two angles there have to add up to 180 because they're co-interior. So if we just take that answer away from 180, that'll give us our answer for this one. So 180, take away the 135, and that leaves us with 45 degrees. Now obviously this is the first time we're in this sort of the questions that we've been looking at where this has come up, but that is a 2-digit angle. So to give the bearing for that, our answer would be 045 degrees. There we go, and we'd have to give that in 3 digits now that we've got a 2-digit angle coming up. So that would be our answer. Obviously we get the same answer the other way, because if you think about it logically, over on the right hand side here, looking at this area again, if we had have done the corresponding angle method up to this point here, that green angle there is 180 degrees. So if we do 225, take away that 180, it leaves us obviously with 45 degrees there, which is then corresponding with our initial angle. So it's all just a bit of logic there, obviously applying the 180 degree angle, which is why we can do that for both methods with our straight line and with our co-interior angle there. But there is just a couple of ways to be thinking about these questions, and obviously there's a couple now for you to have a go at, so here they are. Okay, so there's two questions here, very similar to the ones that I've just done. So have a go, try drawing out the diagram. If you get it wrong when you do the first drawing, just redraw it in the other direction. But there you go, pause the video there, have a go, and we'll go over the answer in a sec. Okay, so C is a town. The bearing of C from A is 65 degrees. So here we go. We've got A and we've got C. And we've got our north lines getting drawn in. There we go. And it says that this angle here is 65 degrees. There we are. And it wants to know the bearing of A from C. So it wants to know this full angle here. So again, completely up to you what method you use. I'm going to extend the line. So this is 65. This is 180. We have them both together, and 180 plus the 65 is 245 degrees. There we go. So there is our bearing. I think I find that method quite easy, and I sort of prefer that to the other one actually when they're a little bit more simple like this. So A is a town. The bearing of A from B is 232. So let's have a go at this. So A to B. There we go. That's going up there. And we've got our north lines in. So it says that that is A from B. So that is the full angle round here. So that is 232. There we go. And then it wants us to find the bearing of B from A. So B from A is this one here. So that's the one it wants to know. So we need to find that angle there. And again, I'm going to just find this one to start with. I'm going to do the co-interior one for this one. So 360 minus 232 is 128. There we go. So that's 128. And then obviously these two angles here have to add up to 180. So I'll do 180, take away 128. And that leaves me with, let's have a look, minus 128. That leaves me with 52 degrees. There we go. So finishing that off as a bearing is 052 degrees. There we go. And there's our final answer for that one. Right, let's have a look at something slightly different, applying these into a bit more of an angle problem. Okay, so we've got something a little bit more interesting here. Now it says C is due south of B. That's just telling us obviously it's a straight line there, but obviously using directions instead of just saying it's a straight line. Another wording for that we could have questions that say things are due east or due west. So if it said something was due east of B, that would obviously be a straight line going to the right here, and it would tell us that this is a right angle. So when it's saying it's due south, it's just basically telling us that from here to here is 180 degrees. Okay, that's all that's telling us. So we'll get rid of that. It says work out the bearing of C from A. So C from A is telling us how do we get to here from here. And obviously we've already got part of that angle there. We've got the 62, but we need the full angle all the way down to this point here. Okay, so a bit of an interesting question. We've got some parallel lines going on. We've got a triangle that's involved there. We've got some lines here on the triangle telling us it's an isosceles triangle. Okay, so pause the video, have a go, see if you can get the answer, okay, and we'll go over the answer in a sec. Right, okay, so let's have a look then. So we've got a couple of angles, let's have a look, let's get rid of some of this working out here. There we are. Right, so we've got this angle of 62. Now to get from anywhere from that 62 up to the top, look, we can work out this angle here. In fact, we can even work out the angle here with the x next to it as well. So we can just think about some of the parallel line rules. Now, from what we've done so far, we could just work this one out. Obviously, they've got to add up to 180. So 180 take away 62 tells us that would be 118 degrees. Okay, there we go. So my working out for that was 180 minus the 62, and it was 118. Now for this particular question, because of the nature of the sort of all these lines that are drawn on, we could have actually used another parallel line rule, and that was obviously going up here and finding an alternate angle. Alternate angles are equal, aren't they? So there's a lot of parallel line rules that seem to be going on here, but we could have actually just found it that way. So we could actually just straight away say this one's 62 degrees. There you go, because alternate angles are equal. And obviously we're going to find that anyway, because we've got the 118, and we're going to take that away from 180 on a straight line there. So we'd also get the 62 that way. But then obviously we can move further into this triangle. Obviously we know this is an isosceles because it's got these little dashes on here. So we can find the two base angles of that isosceles. So we can take 62 away from 180. So 180 take away 62, which obviously leaves us with 118 degrees again. And then because it's an isosceles, that's going to get split in two. So if we divide that by 2, that'll be 59 degrees for each angle. So each angle down here is going to be 59. There we are, that's 59 and that's 59 as well. And now we have all the information that we need to get this bearing. So it says the bearing of C from A, which is the full turn there up to this line. And we've got the two angles there now. We've got 62 and the 59. So if we combine those together by adding them together, 62 plus 59, and let's see what that gives us. That gives us 121. There we are. So it's 121 degrees for the combined angle there and the full bearing of C from A. There we are. Right, got one more question for us to finish off with, just using a little bit of extra maths going on in this particular question. Let's have a look at this one. Okay, so this type of question here is really where the question starts to bridge from the sort of foundation questions up to these sort of higher questions where it's involving a little bit more maths. So this is quite a challenge question for anyone that's doing the foundation, but this is a good bridge for the people that are doing the higher exam, and this moves into the trigonometry bearings sorts of questions. So I've given you a big hint there, it does involve some trigonometry. Okay, we've got a right angled triangle involved, so straight away I would be thinking about Pythagoras or trigonometry just seeing that image, but this is going to involve a little bit of trigonometry here because we are working out an angle, we're working out a bearing, and whenever you're looking at right angled triangles with angles, you're definitely going to be using a bit of SOHCAHTOA there. So for this particular question, I'd encourage you just to pause the video there and have a go and see what you get, and we'll go over the answer in a sec. Okay, it says work out the bearing of B from A and give your answer correct to the nearest degree. And there's also a hint there that you're going to be using a calculator, look, because it says correct to the nearest degree. So it's a hint that you're going to get a decimal, and that's a bit of a hint there that you're going to be using a bit of SOHCAHTOA as well. So it says work out the bearing of B from A. So B from A is this angle here. So that's what we're trying to work out. Now at the moment we've got a right angled triangle here within these this sort of image here that we've got. So both angles, both lines are pointing up to north. We've got our right angled triangle. We've got two lengths on that right angled triangle. So actually using a bit of SOHCAHTOA, we could work out the size of this angle X just here. So actually if we label this triangle up using our SOHCAHTOA rules, we've got the opposite, the angle here. We've got the hypotenuse here. We've got the adjacent here. And obviously we need to work out which sides we're actually going to use. So we're going to use the hypotenuse and the adjacent. So we're not bothered about the opposite there. So it's A and H, which is our cos formula. So we're going to use CAH. And again, if you're not entirely sure on trigonometry, check out my trigonometry playlist. And obviously you can have a look through some of the videos on SOHCAHTOA there, working out angles and side lengths. So if we're trying to work out the angle, we're going to do cos minus 1. And then A over H. And A is 60. And H is 110, so it's 60 over 110. Typing that into the calculator, we get 60 on the top, 110 on the bottom, and that gives us an angle there of 56.94 degrees. There we go, 56.94 degrees. I've rounded that there to 2 decimal places. Once my answer correct to the nearest degree, so that's going to be fine for me to just round that. Now thinking about what this actually means in terms of this diagram, if I write 56.94 just here, there we are. We only want to know this little gap just here, but if this is a right angle on the right here, then this is also going to be a right angle on the left. So this is going to be a right angle as well, as both those lines are pointing north. Those two angles are going to be the same because they are co-interior again. Okay, obviously just one is 90, so the other is going to be 90. So the total of those two angles has got to add up to 90, and we've already got one of them. We've got this one here, 56.94. So to get the angle on the other side of that, the little gap, all we need to do is take that away from 90. So 90, take away 56.94. Let's just do that on the calculator. Take away 56.94, and that equals 33.06. And to the nearest degree as an angle, that's going to be 33 degrees. But obviously we're giving it as a bearing, so that's going to be 0.33 degrees to the nearest degree. And there's our final answer for that question there, involving a little bit of trigonometry and bearings. Now the next video that I'm going to make is going to be for the higher paper only, but that's going to go really a lot more into depth into these sorts of questions where we've got trigonometry and bearings, and they are really quite tricky, but I'm going to link that in the description. Okay, so do check that one out if you are doing the higher paper and you want to push yourself a little bit more on this topic. But otherwise, that's the end of bearings there. I hope you found that useful and helpful. If it was, please like, please comment, please subscribe, and I'll see you for the next one.